Today we're going to talk about graphing compound inequalities. And the biggest thing you need to understand when graphing compound inequalities is these two words and what they mean. And and or. For and, you need both inequalities to be true. So if both inequalities are not true, then it can't be an answer. For or, you only need one or the other to be true. So you don't need both to be true, you need one or the other. And they kind of take on a different look for the different graphs that we're going to do with these. Okay, so we're going to graph a whole bunch of these compound inequality statements and just see what they would look like. Okay, so let's look at some and statements first. So in this and statement, we need numbers that are greater than or equal to 5, and we have x is less than or equal to 7. So when you're thinking about the numbers that would work for that, they would have to be bigger than 5 and less than 7. So you might think, oh, we would get the numbers like 5, 6, and 7 for that. And that's how we're going to kind of graph it. So we're going to make a closed dot, because that's an equal to. At 5, we're going to make a closed dot at 7, because that's an equal to. This one goes this way, and this one goes this way, from what we known before. Since they're and, it's only true when they're both true. So the parts that we don't get is any of the parts where they're not crossing. So we get this area right in here. And again, how you know that area is you want to figure out, oh, what numbers are greater than 5 and less than 7. So it's going to look like a line segment trapped in between these two. Okay. Let's look at this statement right here. So in this one, we have x is greater than 3 and x is greater than or equal to 6. So if I would graph this, x is greater than 3, that would be an open circle, and it would go like this. At 6, it'd be a closed circle, and it would go like this. And if we look at the overlap happens here. So the parts that I don't get is when it doesn't overlap. So this part down here. Again, they both have to be true. And if you think about this, this would make sense. Like if you want numbers that are greater than 3 and greater than 6, well, you just get to pick numbers that are greater than 6. Because if it's just greater than 3, like 5 is not also greater than 6. So again, we worry about the overlap. For this one, we would have x is less than or equal to 2. So that would go this way. And x is greater or equal to 4. So it would go this way. Well, if you look where the overlap is, there is no overlap. And if you read this statement, it doesn't make much sense. Pick a number that's less than 2 and it's greater than 4. Well, there's no number that's less than 2 and it's greater than 4. So this one doesn't exist at all. We would say for this one, no answer. Because there isn't an answer. Because there is no number that is greater than 2, or less than 2 and greater than 4. Let's try some or statements. Now again, I took the same ones and now we're going to make them or statements. As I said before, or just has to be one to be true. So we don't have to worry about both being true. So we need numbers that are less or greater than or equal to 5 or less than 7. Well, that'd be again a solid dot, and this would be going this way. This one would be a solid dot, and it'd be going this way. And we would get, this is our answer. Now, because we don't need overlap, just one has to be true. And if you think about this statement, you should get all numbers when you think about it. You need a number that's greater than 5 or less than 7. So if you pick a number, 3, well, 3 is less than 7, so that works. Or if you picked a number 10, oh, 10 is greater than 5, so that works. You don't need both of them to be true, so you just get to graph 2 on the same number line and just see what you get. Let's look at this one. So we got this and this. Again, I would do the same thing. I'd go x is greater than 3, so I'd make an open dot and have this one go this way. I'd have 6, this is less than 6, so I'd do a closed dot and have them go this way. So my answer would be this right here. And again, if you think about it, it kind of makes sense. You need things that are greater than 3 or greater than 6. So that would be like 7, 8, 9, all the numbers that kind of follow that pattern. So for the ors, again, we just have to graph them and see where they are, and we don't have to worry about overlap. Let's do 2 more. Let's take that one there. And then we'll take this one here. So when you graph 2, you'd get a solid dot at 2, and this one going this way. 4, and this one going this way. And again, this would be my answer. And again, that kind of makes sense. It's got to be less than 2, so this would be my less than 2 side. It's got to be greater than 4, so that's my greater than 4 side. We don't have to worry about no answer because for OR statements, we are not worried about the overlap. We just graph the 2 on the graph, we see what they look like, and those are all our answers. So for AND statements, the big keys to this so that you can be successful, for AND statements, you're looking for the overlap. For OR statements, you just graph the 2 things. And that's it. That's how you would graph compound inequalities.